and welcome to a special episode of NASA Science Live. I'm your host, Joy Ng, and I'm so glad you're joining us today to talk about Comet NEOWISE. As you might have heard in the news, this 3-mile-wide comet is passing through the night sky this month, and you'll be able to look up and see it with binoculars, telescopes, and if you're lucky, even the naked eye. Last weekend, I managed to see it around 4 a.m. in the Chesapeake Bay in Maryland, and it was stunning. But if you're more of a night owl, starting from this week, you'll get a chance to see it in the evenings just after sunset. On social media, we asked you to submit some of your own photos, and we received some amazing images. So keep an eye out because we'll be featuring them throughout the show. Comet NEOWISE was first discovered in March of this year, and it's been putting on a grand show for comet watchers at dawn and now at dusk. It's covered in soot left over from the formation of our solar system about 4.6 billion years ago. And as comets orbit close to the sun, they heat up and spew gases and dust in a glowing head. And this material is what forms the tail that you see stretching across the sky. Observers all over the world are hoping to capture a glimpse of Comet NEOWISE. And today we have two NASA experts here to answer some key questions about this fascinating celestial object. Please send your questions using the hashtag AskNASA or by writing in the comment box wherever you're watching this today. So let's get started. I'm joined by Emily Kramer, who's the co-investigator on the NEOWISE science team, and Joe Macero, NEOWISE Deputy Principal Investigator from NASA's Jet Propulsion Laboratory. Thank you both so much for joining us.
Thanks for having us.
Great to be here.
So we're all really excited about the opportunity to see Comet NEOWISE in the sky. But I'm curious, what is the difference between a comet and an asteroid?
Sure, that's a great question. So comets and asteroids are both objects in our solar system that orbit through the different areas. The asteroids are mostly between Mars and Jupiter, and the comets tend to be in a much wider area. They also tend to be very different in composition. The asteroids are mostly rocky, and the comets are what we might call icy mud balls, so a combination of volatiles such as water ice, carbon dioxide and carbon monoxide, and dust as well.
So how was Comet NEOWISE first discovered?
So Comet NEOWISE was first picked up by the NEOWISE survey at the end of March. So NEOWISE is an acronym that stands for the Near Earth Object Wide Field Infrared Survey Explorer. And this is an infrared space telescope orbiting the Earth in a low Earth orbit, constantly scanning the sky in the thermal infrared, looking for asteroids and comets that come close to the Earth. And so this comet was first picked up at the end of March as part of our automated processing. And so as the data came in, it goes through an automated system that tries to identify moving objects and sends it to our team to review. And so as part of that review, we were looking at it and said, hey, this looks like a comet. We can see a clear fuzzy cloud around it. And so we reported that to the Minor Planet Center saying, here's a new object, and it looks to be cometary. Now, right after we discovered it, we saw that it was going to have a close pass with the sun around July 3rd, and that there was a chance that it could become very bright. And so we were really crossing our fingers, and we got really lucky that it turned out to be a spectacular sight.
Yeah, it's really, really stunning. So why is it named NEOWISE?
So this is a tradition in astronomy that goes back centuries. Comets are typically named after their discoverer, or the first person who reported it in the journals or the letters to their colleagues. Now that most of the discoveries of asteroids and comets are done by surveys, the rules have been that if it's found by the automatic processing of the survey, it's named after the survey. And so because our survey is named NEOWISE, the comet is named NEOWISE.
And is there anything that makes this comet unique?
Well, the fact that we can see it is really what makes it unique. It's quite rare for a comet to be bright enough that we can see it with the naked eye or even with just binoculars. The last time we had a comet that was this bright was Comet Hale-Bopp back in 1995 and 1996. So it's been quite a while, and it's exciting to be able to see this one in this way now.
And why is it that we can see Comet NEOWISE now? I understand at the end of the month, it's going to disappear and not be seen for 6,800 years. So why is that so?
Right. So as I said, when it came by the close pass of the sun in July 3rd, that's when it gets the hottest. And so the sun bakes off these ices that Emily spoke about and turns them into a gas that makes this cloud, this beautiful tail that we see. And that's a combination of the melting gases and the dust that's kicked off by it. And so whether you can see a comet or not and how bright it appears is all a function of geometry. Where is the Earth? Where is the sun? Where is the comet? And so if all of the things line up just right, then the comet is reflecting enough of the sun's light to get to us to appear to be bright enough to see with the naked eye.
And we've had a few NASA satellites that have captured the comet in its images. What can we learn from comets using satellites?
So satellites can help provide us with some really interesting information that we're not able to get from the ground. For example, with the NEOWISE spacecraft, the one that we used to discover this comet, we're able to detect carbon monoxide and carbon dioxide, which is difficult to see from the ground due to Earth's atmosphere. So we're able to get some information that we wouldn't be able to do otherwise. Additionally, with other spacecraft such as Hubble Space Telescope, for example, or SOHO or a few others, we're able to see the comet without the Earth's atmosphere obscuring it, allowing us to get a much more detailed picture of what's going on.
Oh, that's really interesting. Let's go ahead and answer some questions from #AskNASA. Remember, please don't hesitate to send us your questions by writing in the comment box wherever you're watching this, or by using the #AskNASA on social media. So one question we've been getting from a lot of you is, how do I capture Comet NEOWISE in photos? Well, NASA social media specialist Bill Dunford captured some photos last weekend and has shared a few of his tips.
Hi, I'm Bill Dunford from NASA's Jet Propulsion Laboratory. In my spare time, I love to take pictures of the night sky.
I do this using a camera mounted to a tripod and in manual mode so that I can set the camera to leave the shutter open for several seconds to let in lots of light. Recently, I captured these images of Comet NEOWISE. On a clear morning at about 4:30 a.m., I went to a location far from city lights that had a good view of the northeast horizon. I could see the comet with the naked eye, so I zoomed in on it and exposed each shot for about 4 seconds. I also did a little post-processing using photo editing software. Here's an original photo straight out of the camera. I was able to brighten it a bit, draw out the vibrancy of the colors, and clean up some noise. The end result was close to how the scene looked in person, which I have to tell you is beautiful.
So I really hope you get a chance to see Comet NEOWISE and all of the other wonders of the night sky.
So we have another question from social media. Twitter user Fran asks, will the comet keep moving higher away from the horizon every night? Will it eventually be over my head? And can I see it anytime after dark?
So right now it's moving from the morning sky, as you heard, into the evening sky. And so it will be coming up in the evening sky as this next week or two go on. But it's going to be moving further from the sun at the same time. And so there's a chance that it could be getting fainter, or if there's extra activity, it could be getting brighter. So we really don't know what the brightness change will be over time. But it's certainly going to be, after about a month from now, going to be getting much fainter rapidly. It won't be over your head unless you're pretty far north.
Okay, and Twitter user Bardswan asks, now that the comet is more visible in the evening, will it no longer be visible in the morning?
Yeah, so
absolutely.
as Joe was saying,
Go on.
This is the difficult part about doing this remotely. So as Joe was saying, as the comet moves its position in the solar system, due to the geometry, we'll only be able to see it in the evening from after a few days from now. You can see from this picture here how it'll move in the sky as the time progresses.
Fantastic. So Twitter user Andrew Fontura asks, how fast is Comet NEOWISE traveling through space?
So as Emily mentioned before, comets follow these very elliptical orbits. And so when it's farthest from the sun, Comet NEOWISE is almost at a standstill with respect to the sun. But as it fell down the sun's gravity well, it sped up. And so right now it's moving at around 40 miles every second. This is about twice as fast as Earth's speed around the sun. And so as it goes farther from the sun, it'll be slowing down as it climbs back up that gravity well.
Okay, so Rishikesh Kankal from Twitter asked, what is Comet NEOWISE's tail made of, or how much water is in the comets?
Right. So there's actually, usually you see two different comet tails. You can see the broad dust tail, which kind of has this pale yellowish gray color. And then frequently you will also see the ion tail, which is made of ionized gases. So both of these come from the comet's nucleus and are lifted off as the comet gets closer to the sun. And because they have different compositions, they just react a little differently to the solar radiation pressure. That is to say, the sun's how the sun interacts with these particles. So the two different kinds of particles tend to get spread out. So the other question, the other part of the question was about how much water is in a comet. So this comet is about 3 miles across, and most comets on average are about half water and half dust. And so I actually did a little quick back of the envelope calculation on an actual envelope. As you can see right here, this is actually how a lot of scientists do these calculations a lot of times. And my quick calculation is it's probably about 13 million Olympic swimming pools worth of water. So that's a lot of water.
Wow, that is a lot of water. Thank you for doing that calculation.
No problem.
So Palak on YouTube asked, how fast would the comet be seen moving to the human eye?
You can't really see it with the human eye, although you might notice it moving a little bit with respect to the background stars if, for instance, you have a camera on a tripod and you're taking images over time. But on minute to minute, it's not moving very fast. If you take 2 images night to night, you will see it distinctly moving against the background frame of the stars. So you can see that motion over even just 1 day.
Fantastic. So we have another question from Twitter. Daryl Leslie asks, will I be able to see it from the UK?
Yeah, you should be able to see it from most places in the Northern Hemisphere, so long as you have a reasonably dark sky and have a clear view of the northwestern horizon. Now, I know that some folks in the Northern Hemisphere, especially those particularly far north, are in of course, we're all in the summer now, and if you're particularly far north, you don't get a lot of dark time. So that might make it a little more challenging, but I would say still try to go for it. It'd be really neat to see if that would work.
Okay, so we have another question. Sagat Gautam from Twitter. They ask, how was NEOWISE formed?
Sure, yeah, I'll take that one. So comets were formed in the very early days of our solar system, back when everything was just this big disk of gas and dust, and we didn't even have the planets or anything formed. So you had the star, our protostar, early sun in the middle, and then just this big gas disk of gas and dust. And then things started collecting into into what eventually became the comets and the asteroids and the planets. And the asteroids tended to stay mostly in the middle of the solar system, whereas most of the comets tend to get flung far away. And so they've been in what we like to call cold storage for most of the age of the solar system. And that's why they're able to have these ices on board, which help to form these dramatic tails, as we see with Comet NEOWISE.
So the number one question we're getting from social media is, can I see it from my part of the world? And can you explain where Comet NEOWISE is visible across the globe right now?
So yeah, as Emily mentioned, if you're in the Northern Hemisphere, you can see it. As the next couple days progress, we'll be getting higher in the evening sky. So you're going to want to look northwest, right under the Big Dipper. So as this graphic shows, you can see where the comet was a few days ago with respect to the dipper in the Big Dipper, to the bucket. So that will be moving up, and in this image to the left a little bit, so getting more underneath the Big Dipper. What you want to do is go out right around the time that the first stars start to show up. And so you're not going to be able to see it before that. It's probably about as bright as some of the stars in the Big Dipper. So find out what time your local sunset is, go out about 45 minutes after that, and wait until the first stars start to appear, and that's when you should start looking with your binoculars.
Okay, so is it visible from the southern hemisphere at all?
Unfortunately, no. Not right now.
That's a shame. So Harry on Twitter asks, what is the diameter of Comet NEOWISE? Is it an interstellar object?
Yeah, so from
Emily, you take it.
So from our initial data with the NEOWISE spacecraft, we're able to make a preliminary measurement of the size of the nucleus. We found out it's about 3 miles across, or 5 kilometers for the other folks who might use the metric system. And this one, we know it's not an interstellar object. By watching its motion, we can see that it's bound to the sun's gravity. So it's coming in very rapidly, and then it's going to go far back out again, but then it should come back in again in about 6,800 years.
Fantastic. So Twitter user Aluz Okizi asks, I'd like to know if comets have regular orbits, and I'd also like to know if the formation of comet tails leads to the reduction in mass of the comets, and if their mass is replenished when their orbit is farther away from the sun.
So yes, comets do have regular orbits. This one is on an elliptical orbit. It's a very stretched out ellipse, but it's still an ellipse, and so it will go around the sun every 7,000 years or so. And each time it does, it loses some of its mass. Now, there's nothing out there right now to replenish it. All of the gases and dusts that Emily talked about that were there when it formed are no longer there. They've been blown out by the sun's solar wind over the last billions of years. And so it's constantly losing mass, not replenishing it. And so each time it goes by, it will lose a little bit more until one day it just disintegrates.
And how long does that process take?
Process, go on, Emily.
Yeah. No, go ahead.
Okay. That process it depends on the comet. Some comets lose mass very quickly. If this is their first time in the solar system and there's not much in the way and there's a lot of ice on the surface, it can lose that material very quickly. As the comet gets older, the ice has been blown off and the dust has remained, and it gets this crust, basically, that shields it. And so comets, each time they come by, are expected to get a little bit weaker, a little bit less powerful in terms of the amount of material being shed off. And so they might still have ice subsurface after we call them dead comets. It's just that there's a thick layer of rubble that protects them from the heat of the sun.
So Kate Staples from Twitter, they ask, why is there a public conference about NEOWISE tomorrow with NASA defense officers? I find it all very sudden. What are the potential risks for our planet?
I'm going to let Joe take this one.
Okay. There is no risk to the planet from this. This object is nearly 3/4 of an astronomical unit away from us right now. That's 1 astronomical unit is the distance from the Earth to the sun. So this is very far away from us, and it's not coming anywhere near us. So there is no threat. The reason that the Planetary Defense Coordination Office is having a press conference, I believe right after this, is because NEOWISE is under the umbrella of the Planetary Defense Office. And so this is one of our goals, is to search for hazardous asteroids. When we do that, we find all kinds of great other things like Comet NEOWISE. But because this is the office that is basically allowing NEOWISE to operate and giving us our guidance, they're the ones who are going to be talking about what we found and all the cool stuff that comes out of it.
So there's another question on Twitter from Ansh, and they ask, are there any chances of NEOWISE becoming a great comet and turning it exceptionally bright? If yes, what are the chances?
So comets are notoriously hard to predict in terms of how bright they'll be. And even for comets that we've seen before, this is a real challenge. But for Comet NEOWISE, the first time that we're seeing it, we don't really know for sure. Because it's already past its closest point to the sun, so it's already past the point where it's gotten the most heat, it's unlikely to become tremendously much brighter than it is. But comets surprise us. So I would say keep a lookout, and who knows? We might see it become a great comet, but it might just fade away. That's one of the exciting things about studying comets, is that you never really know.
And we're all
Well, fingers
exploring this together right now.
It's true.
So Terry on Facebook, they ask, why are there 2 or even 3 tails with comets?
Yeah, so as I had explained before, comet tails are made up of dust and ions and ionized gases. So that broad tail that you see is the dust, and it interacts with the sun's solar wind a little differently than the ionized gases. And sometimes you even have that third tail, which is the sodium tail, in very rare cases where you have a particularly bright comet that's having a lot of activity, having a lot of dust and gas come off the surface. Most of the time, the comets we see are too far or too faint to actually see that third tail. So it's very exciting when we do get a chance to see that third tail.
So we have a couple of questions about when was the last time Comet NEOWISE appeared? Or is this the first time it's visited us?
So its orbital period right now, from our current measurements, is around 6,800, 6,900 years. So that would mean that the comet was here last about 7,000 years ago. However, as the comet is outgassing, as material is being kicked off, these act like thruster jets. And so comets very frequently change their orbits, either subtly or sometimes dramatically, from one pass of the sun to the next. So while we can go backwards in time and say it was probably here around 7,000 years ago, we're not sure if it's been on this orbit for many more passes prior to that, or if it had been dramatically changed for some reason because of the outgassing of the gas and the dust.
Wow, and what is the average temperature of a comet? Asked Gina from YouTube.
So comets are pretty cold compared to what we have here on Earth, but they're relatively warm compared to the background of space. So let's see, for an exact number, I'm going to have to pass it over to Joe. I'm not great at doing these calculations on my head, which is why I had that envelope where I did the other calculation.
So for these kind of objects, the temperature of the object is really just a function of how far it is from the sun, because that's where it's getting its heat from. And so because this comet is passing about the same distance from the sun as the Earth is, just in a very different spot, it's going to have about the same temperature. So if you were standing on the surface, it's probably close to room temperature. But as Emily mentioned, as it goes further out, it's going to cool off and drop dramatically. And so it's going to get down to liquid nitrogen temperatures, then liquid helium temperatures, before it goes out into its cold storage, which is only a few degrees Kelvin above absolute zero.
And you said that they can change trajectory, but when comets lose mass, do their orbits change? And that's a question from Comet on Periscope.
Yes, absolutely. The orbits can change. It depends on where the thruster is coming out from. Comets, we thought of them originally as snowballs that were just losing mass everywhere, but from the Rosetta mission to 67P Churyumov-Gerasimenko, we saw that it actually came out in these very narrow jets from certain parts on the comet's surface. And so each of those jets can cause a little push, and it can either change how the comet spins, or it can change the comet's entire orbit around the sun. And it all depends on where that jet is and where it is when it fires off.
And so Samir on Facebook, they ask, is this comet disintegrating as seen in some of the recent photos taken by astrophotographers?
Yeah, sure. So I took a look at a few of those from a couple days ago, and what I think we're actually seeing in those images is not necessarily the comet breaking up, but actually a jitter in the way the camera is set up. So if you have a camera that's very stable, you'll get a nice clear picture of the comet. But if it shakes a little as you're taking the image, it'll look like the comet is breaking up or splitting up. And this is actually a really common thing that even professional astronomers have to deal with. So if you see a little bit of jitter in your objects or in the images, that's pretty normal. That doesn't mean the comet's breaking up. That just means that you might need to try to secure your camera a little bit more tightly before trying to take another long exposure.
We're getting some great questions from social media. So we have Harlan Lilly on Periscope. They ask, what does the color of NEOWISE's gas plume tell us about its chemical makeup?
Emily, you can take this one.
Sure. Yeah, so we can use what are called spectra to help us understand the composition of these comets without even having to go there, which is I think is really fascinating. Just basically by the color of the light, we can tell what it's made of without even having to touch it. So what we know from comets is that generally these ion tails are made of hydrogen cyanide and a few other what we call carbon-bearing molecules. And so yeah, hydrogen cyanide tends to be one of the biggest ones. So you wouldn't want to breathe it in if you were standing on the comet, as Joe had suggested.
Well, we have learned a lot about Comet NEOWISE today. Emily and Joe, thank you so much for joining us.
You're very welcome. It's been a lot of fun.
Yeah, a lot of fun.
And thank you for joining us from home. If you want to learn more or take a closer look at viewing tips of Comet NEOWISE, visit go.nasa.gov/spot Comet NEOWISE. So we're going to end this episode with a fun video that has all you need to know about near-Earth objects and NASA's mission to find, track, and monitor them. Until next time, happy sky watching.
Not special. There's thousands of people out here that have thousands of jobs, and each one's equally important. The only unique thing about us is we have the last hands-on job before the bird flies.